The next thing we want to be able to do is find the arc length from one point on a curve to another. So what that means is, let's say I give you a curve. I want to find the distance from this point to this point. Previously, what you did is you found the distance between 2 points on a line. And in algebra, when you did this, you can use the distance formula. We want to be able to do it for any curve, regardless of whether it's straight or a curve. So we're going to do one problem that you can do both ways, and you'll see you get to the same answer. So if I ask you for arc length between 2 points, I'm just asking for the distance from one point to the other. So since I give you 2 points, and we're going to assume that this is 2 points on a straight line, let's just go ahead and use the distance formula. So if I use the distance formula, remember from algebra, it's x2 minus x1 squared plus y2 minus y1 squared. So your distance between these 2 points along a straight line would be square root of 2. Now what we're going to do now is use a formula for arc length. So this works for whether it's a straight line or it's a curve, and basically it says what we're going to be doing is it's basically using the distance formula between 2 points really close to each other, and then the integral symbol is saying you add up all those distances to get the distance from here to here. Okay? So the only thing you need is the derivative of the function. So if this is a straight line, your f prime is just really the slope of this line, which is really 5 minus 4 over 2 minus 3, which happens to be negative 1. So using this formula, it says the arc length is going to be, I'm going to use my x-coordinates. I'm going to add up all the distances from 2 to 3, square root of 1 plus my derivative squared. And notice this is going to give me 2 to 3. This is square root of 2. The antiderivative square root of 2 is square root of 2x. Let's plug in my bounds. I get square root of 2, 3 minus 2, which is square root of 2, exactly the same way I got using the distance formula. So notice for a straight line, the distance formula is probably quicker. But you do get the same answer using the arc length formula, which works for a straight line or a curve. Distance formula only works for a straight line. Okay, so now let's go ahead and try it for another line, and this time we're going to go straight to the arc length formula. So arc length formula says, I'm going to do this in terms of dx. So I'm going to use my x-coordinates. I'm going to go from 0 to 3, square root of 1 plus, my derivative in this case would be 2 squared dx. And for the arc length problems, we're going to just go ahead and use our calculator for the integration. And if you punch this in your calculator, this is the value that you get, 6.7082. Okay, let's try one for a curve. So the only thing you really need is your f prime. So bring down the 2/3, so I would get 2x to the negative 1/3. So arc length, again, I'm going to do this in terms of dx. So I'm going to use my x bounds. I'm going to integrate from 8 to 27. Square root of 1 plus, this is my derivative, squared dx. Use your calculator, 24.2447. Arc length should always be positive. We're talking about the distance between 2 points. Okay, one last one. This one, notice, okay, it is going to be easier to solve this for x. So I'm going to solve this for x. So x is really y cubed minus y. So this problem, I'm going to need to do this problem in terms of y. So I'm going to go ahead and use the y coordinates. So I'm going to integrate from negative 1 to 2, square root of 1 plus, my derivative is 3y squared minus 1 squared dy. And again, use your calculator. It doesn't matter that this is y. You're still going to type in as x on your calculator. This is 8.725. So for arc length, you can do it in terms of x, or you can do it in terms of y, whichever variable it's easier to solve the equation for. Because when you're looking at a curve, you can either add the distance horizontally, or you can add the distance vertically when you stretch this out. But regardless of which way you do it, the distance between one point to the next should be the same value.